been an incredible journey. I hope today you enjoy our last panel. We have great speakers lined up to discuss the Artemis missions. So before we get started, I want to first of all thank the Houston Museum of Natural Science for once again hosting us today. I want to thank Astrolab for one of our speakers, John, who will be arriving a little bit late, but he'll be here. And finally, since this is the last of our series, I want to acknowledge a few of our local organizing committee members who have been instrumental on setting up all of the panels that you guys have experienced for the past few weeks. So please, an applause for Brian Rishikoff, James Lewis, and David Rose, who is not here with us. Thank you. Okay, so it is my pleasure to introduce now our moderator, who most of you already know, John Conley. John Conley is currently a professor of practice in aerospace engineering with Texas A&M. Prior to joining Texas A&M, he was working for NASA for 36 years, where he held roles with the lunar lander design, lunar surface systems, and human Mars mission planning. From 2014 to 2016, he was also an SSP director, and he led SSP 15 in Ohio and SSP 16 in Haifa. He also has been leading the rocket launch competition for the past 25 years for SSP. So please help me welcome John Conley.
Thank you, thank you. We have an extraordinary panel today of people who are associated with the Artemis program. And so before we bring them forward, I wanted to give you a little history of Artemis because I feel like I've lived much of this. So Artemis is occurring at a point in time where all the pieces are coming together. And this is important. It's systems engineering on the highest level. We tried, NASA has tried going back to the moon a couple times. We had something called the Space Exploration Initiative back in the late 80s, early 90s. That basically gave us some designs for large launch vehicles, landers, and surface systems, but it really never went anywhere politically. In 2004, we began the Constellation program, which ran until 2010. It again had more pieces to it and more of the things that you need to make a program work politically and sustainably. And it gave us what has become the Orion vehicle, the Space Launch System, which back then was called the Ares 5, and the Exploration Ground Systems that are the necessary first step down at the Kennedy Space Center. So you can see on my little timeline behind me, we have these kind of gaps in time. About every 14 years, NASA has tried to put together a program to take us back to the moon and onto Mars. What's different this time is that many more of the pieces are in place, and it's more likely that this will actually work because we've learned from those first two iterations. So in the Artemis program now, we have, of course, the Orion vehicle. We have the SLS, the Big Heavy Lift Launch Vehicle. We have the HLS, the Lunar Lander. We have the Exploration Ground Systems. We have rovers and spacesuits under the EHP program. We have the Gateway, a small space station orbiting the moon. We have many other pieces that are all necessary to begin the exploration back on the moon, then sustain it as we add things like rovers and habitats to all that. So we're at an extraordinary time because all the pieces are falling into place, and you are all very lucky to be part of the Artemis generation. So with that, let me introduce our panel today. First, I'd like to introduce Branielle Rodriguez. Branielle is NASA's Orion Manager for Program Integration and the Artemis II Vehicle Manager. Branielle, please join. She oversees the end-to-end development, production, and mission execution of Artemis II spacecraft. Prior to joining the Artemis program, she led the International Space Station engineering teams in real-time anomaly resolution, critical dynamic events. This is very impressive, by the way. Thank you. Fills up many pages. Oh, yeah. Day-to-day operations, as well as designing, developing, and flying spaceflight, life support, and habitation hardware. Please welcome. Next up, we have Emma Lanehart, who some of you know. Emma is the business manager for NASA's Gateway program, a space station that will orbit the moon. Previously, she worked in NASA headquarters, the White House, the Space Policy Institute, and as a private sector consultant. She attended the ISU Space Studies program in 2008. Welcome back.
Thank you.
We have Lisa Hammond. Lisa is the Associate Program Manager for NASA's Human Landing System, a crewed vehicle that will put the next 2 Americans on the surface of the moon, dock with the Gateway for crew transfer, take large cargoes to the surface, and support long mission durations. Previously, Lisa worked exploration systems development at NASA headquarters on the Orion program, Artemis 1 mission, and at the JSC Engineering Directorate. Thank you. Welcome, Lisa. At some point in the next 30 minutes or so, we'll welcome the 4th member of our panel, John Murator, and I'll introduce you to him when he gets there. So with that, we're going to get started, and we'll start by handing the microphone to Branielle.
All right, I get to grab one of
Yes.
Perfect. All right, good evening. Welcome. I'm Branielle Rodriguez, as he mentioned, and I'm here today to talk to you a little bit about Orion. It's my personal favorite of all the Artemis programs. I'm sorry, ladies, but it is. And I have a few charts, if we want to go ahead and pull those up, to get you a little bit familiar, if you haven't already been familiar with the Artemis program. Oh, look at that. All right, here's a quick video.
It's a new era of pioneers, star sailors, and adventurers.
We're going beyond anywhere we ever went for Apollo.
Splashdown. Orion, back on Earth.
And there's a lot more coming.
Our destiny is always to go and see what's further and what's next.
They're actually metal is being bent, shaped, formed to build the things that we're going to use.
We are going. This is reality.
NASA is at a historic inflection point, poised to begin the most significant series of science and human exploration missions in over a generation.
Astronauts will live and work in deep space, and will develop the science and technology to send the first humans to Mars.
I'm really looking forward to all the science we'll conduct on the moon, the samples we'll bring back, the knowledge we'll gain from understanding the lunar environment better than we ever have before.
The more nations and companies at the moon, the more we learn, increasing our capabilities while strengthening things right here on Earth.
We are going to the moon to learn how to live on other planets for the benefit of all. Let's go.
So John, you mentioned earlier that, we're trying, but we are going. We absolutely are going. So I am just one of many program represented here that actually make up the entire mission of Artemis missions. If you've ever heard the saying, it takes a village, it's never true when it comes to Artemis. It takes a lot to go back to the moon and to do what we want to do and explore. And so it really does take all the best, and the best are comprised, we actually have 6 different programs. You see a lot more pictures up on the screen, but it really truly represents all the technologies, all the capabilities that are necessary for us to go back to the moon, explore, and set ourselves up for Mars. So my personal favorite is Orion. I have no shame in stating that. So this is Orion. So I am the Artemis 2 vehicle manager, which means I do see the end-to-end production, design, testing, qualification, delivery, and then mission execution of the Artemis 2 mission, which is of this beautiful spacecraft. Right in the middle is our crew module. It is essentially the pressurized compartment of the vehicle where we can put 4 crew for up to 21 days of consumables. It's a beautiful beautiful piece of hardware that is built down at Kennedy Space Center in the operation and checkout facility by Lockheed Martin. They are a prime contractor and do all the building, designing, as well as integration. Right below that is what we call our service module. This is our European service module built by ESA through Airbus in Bremen, Germany. And so it is what I like to call the powerhouse. It is the engines, it's your propulsion systems, it's your power systems. It's got your life support tanks involved. It's got your thermal systems involved in it. So it's really, truly the powerhouse and doesn't necessarily get enough credit because it brings us into space, allows us to live and breathe, and then we get rid of it before we come back home. And then right above that is something that is absolutely necessary. It's the tip top of the rocket when we sit on top of the Space Launch System. It's the launch abort system. Hope to never have to use it, but in the event during ascent, we have to pull the crew away from any off-nominal condition. The launch abort system pulls the capsule away from about 0 to 400-ish miles per hour in about 2 seconds. We have a total of 8 different motors. The attitude control motors will take the module, try and center it, bring up a crew safely back to home. The only motor that will go off every single time is what we call our jettison motor. So if everything goes nominal during flight, we actually jettison the launch abort system about 3.5 minutes after flight. So it's just a very beautiful ship. So where are we at? You saw some amazing video. I'm sure many of this room probably watched, if not were there, for the Artemis 1 launch in November of 2022. A beautiful 25.5-day mission where we went out and we tested our spacecraft. We brought it to extreme conditions, tested out our guidance systems, and brought it back home safely. And now we're gearing up for Artemis 2. We have 4 phenomenal astronauts that could not be more excited to be represented on this vehicle and are actively involved on day-to-day operations of it and are already training. In Artemis 2, it's another human test flight. It's a shorter mission. I'll talk a little bit more here in just a moment about what it all entails, but it's going to set us up then for Artemis 3, where Lisa and her team are going to be geared up, ready to meet us out in lunar orbit, and where we can dock with the lander and bring the crew down safely to Earth. And then we're going to go hang out with Emma on Artemis 4 and help her build her space station out there, Gateway, and we're going to tug out a component of the Gateway module. So we're really geared up and ready, and I can tell you that 2, 3, and 4 modules, those spaceships are already in production down at Kennedy Space Center. So what's new for Artemis 2? Quite a bit. One, people. We're really tough to fly, by the way. We're probably the hardest thing in human spaceflight is flying and keeping us alive and bringing us back home. But a lot of it is your life support systems. We're flying life support systems for the first time on Artemis 2, and we're also flying displays and controls. We didn't have those on Artemis 1. You didn't need them, I'll be honest. We all flew it from the ground. But on Artemis 2, the crew's going to be able to fly and manual pilot the spacecraft. So those are some of the biggest and most significant changes in there. And then, of course, the launch entry suits, those beautiful bright orange suits that the crew wears. Those are all brand new and custom fit for the crew. So quite excited. And here's the spacecraft. When I say we're off and going, I'm not kidding. We had this vehicle down in what we call a massive altitude chamber. We conducted electromagnetic interference and testing on it just recently, and actually about a week and a half ago, I brought it completely down to vacuum, not only the chamber, but then the spacecraft itself, and tested out the systems. Then we craned it, which you can see in the, maybe you're right, picture of the vehicle. We craned it out, we put it back in, and it's going through our final checkouts and assembly so that we can hand it over to our ground teams at Kennedy, where they start actually stacking it on top of the SLS. And that, I think, is my last slide, and I'll hand it over to Emma.
All right, good evening. Congratulations, everyone, on being done with your departments. Woo! All right, I've spoken with some of you about Gateway. We'll do an overview of this lunar space station, and I'm really looking forward to the Q&A and for y'all to hear more about how we all work together, because it absolutely does take a village. Each part of this enterprise has to focus on excellence and deliver, but also integrate with all of the other pieces across the Artemis campaign. The Gateway is a lunar space station that we are building with commercial and international partners. Our primary international partners are the Canadian Space Agency, JAXA, the Japanese Aerospace Exploration Agency, the European Space Agency, and now the MBRSC of the United Arab Emirates, our brand new partner on this endeavor. Gateway will be built in pieces over time, very similar to the way we constructed the International Space Station. Piece by piece, we will be bringing more components of this space station together and docking them in orbit around the moon. Some of them are launched on commercial rockets, but many of them are launched on the Space Launch System and delivered by Breniel's beautiful spacecraft, the Orion. It's gorgeous, yes. For each of these missions, starting with Artemis 4, we will also have Lisa's landing systems there, and some crew will remain in the Gateway, and some will go down to the surface. Oh, went too far. Space stations are complicated creatures, and for us, this all comes together with a remarkable number of commercial and international partners. Truly a global endeavor, and I can't wait to see it fly. Y'all will probably ask me when the first pieces of the Gateway will be ready to launch. We are targeting our first two pieces, which are the Habitation and Logistics Outpost, HALO, and the Power and Propulsion Element, which will fly on a SpaceX Falcon Heavy in 2026. We are also rocking and rolling over here in the Gateway program, where we're not just PowerPoint. So we have pretty hardware pictures too. So just some of the incredibly recent activity that we have going on, again, all over the world. We have our solar electric propulsion thrusters being tested at the Glenn Research Center. That's in the top left-hand corner, that beautiful blue glow that you see. Top right is our Habitation and Logistics Outpost, HALO, going through its stress tests in Italy. Bottom left, also in Italy, while Thales Alenia Space is building the HALO habitable element, they are starting to build the international habitat at the same time. So those are some of the first forgings of the iHab. And in the bottom right-hand corner, brand spanking new picture, we have our propulsion tanks that are going to fly in the Power and Propulsion Element. This is them pictured on the factory floor, but since this picture was taken, all of them have been integrated into what we call the central cylinder of the Power and Propulsion Element, and that's all being done out in California. That's the status of Gateway. We're incredibly excited to be building this lunar space station, and for now, I think I'll hand it off to Lisa.
Can you hear me? Real close. Hi, I'm Lisa Heyman, and I am the Associate Program Manager for the Human Landing System. We have two primary objectives as we got started. One was to invest in the commercial partners and commercial industry to advance their knowledge of space and to create innovations that we can use to help us meet our endeavors. The second is to, now that's too loud. That was too loud. The second piece is to create a capability to have a sustaining presence on the moon, on the lunar surface, and to be able to allow the crew to be able to build the Gateway and for our use to go to the lunar surface and be able to dock with Orion in order to get the crew members on the human landing system and down to the surface. So we've got a lot of integration that happens between all of us, and there's also integration that happens with other elements, as was pointed out. That integration activity is huge because it also impacts our commercial providers We have two for our human landing system. One is the SpaceX, and the other is Blue Origin. And we really wanted to be able to, as I said, invest in these commercial partners, help with the innovations, be able to utilize their history and their experiences and combine those with ours to be able to create the best possible capability to be able to leave Earth and go to the lunar surface as efficiently as we can and be able to sustain that capability. I'm going to start these charts. So we've got SpaceX's Star. Starship. I'm looking at her, I'm looking at this, our Starship, and then we've got MK2 for Blue Origin. Those are illustrations. Those designs are not set just yet. We've gone through a number of design reviews, requirements reviews, and design reviews over the past year or two, and every one of their reviews have been passed successfully. So we are very excited about being able to move into the end of the fiscal year, into next year, doing more integrated tests for SpaceX because they are dedicated to Artemis 3 and 4, and then Blue Origin for Artemis 5. And that is pretty much the chart that we talked about just now. Starship has been under development, and we use an insight capability with each of the providers. We are buying services from both of these providers, and we are partnered to be able to share that information that we have from previous and all of our history with NASA. And thus far, Starship has had 4 successful integrated flight tests. They've been successful at re-entry at the highest peak of, at the atmosphere heat highest peak, and they've also been able to simulate their ability to have a vertical landing on the ocean surface. But that was a simulation. There will be a test at the end of this year, early next year, to help us build confidence heading into the next design review to ensure that we've got a solid design. Let's see. This is a ConOps. We call it a concept of operations, and I call it a ConOps. I'm trying not to use acronyms here. I'm sorry. We are buying services, and SpaceX will launch. They have 2 launch capabilities, one at KSC and then one here in Texas at Boca Chica. They've launched the last 4 integrated flight tests from Boca Chica, and they've been successful at doing that. They are still working on being able to launch, and if you can, it's really hard to see from here, be able to launch the crew, be able to loiter for a period of time, be able to have propellant transfer, which allows us to have more mass for payloads and other capabilities from Earth to to the orbit and then to the lunar surface. So they will be, both providers will have propellant transfer capability for lunar before going to the lunar surface, and then be able to come from the lunar surface, dock with Orion, transfer the crew, and be able to loiter for a period of time. We've got quite a few tests that SpaceX has been doing. I won't talk about all of their tests. I have to be really careful about proprietary information, but I will tell you the flight tests are most important and have proven to be most beneficial In addition to that, we've got testing for communications that are ongoing. We've got crewed suit tests with interfaces with the vehicle mock-ups, and we've also have elevator tests. That is how the crew will leave the spacecraft and get down to be able to do the exploration on the lunar surface. Blue Origin is doing very well. They've completed their requirements review and their first design review. They will be going into a critical design review shortly. They've been doing lots of engine testing. They've been doing a lot of thruster testing, and they've gained confidence in their design in preparation for the next design reviews. This is an illustration of a concept of operations that, I'm trying to see which one it is. I can't see from here. Oh, Artemis 5, so Blue Origin, I'm sorry. As I said before, each of the providers will do propellant transfer on orbit and be able to go down to the lunar surface, but they will launch with about a 10th of the percent of prop to be able to utilize that mass for other payloads and other capabilities that we'll need on the lunar surface. This is an example of some of the testing for thrusters that have occurred. Another ConOps. Am I going backwards? So this chart talks about the acquisition process that we used, and not so much the process, but what we have established. And these services, this is new for this capability to be able to buy these services. And so we've got a number of contracts with SpaceX and Blue Origin that allows us to get through all the phases of Artemis 3 through Artemis 5 into a sustaining capability, which is post-Artemis 5. And this is an example of what we have. Option A and option B would be SpaceX, and then our app P, and the landing services could be either SpaceX or at the end. That's my point is, at the end, we'll have a sustaining capability, and we should have 2 vehicles, human landing systems, that we can have an option to use as part of the sustaining capability. Am I going the right way? Okay, and I think I'm on the last chart. So I talked a lot about certification, and we're a bit ways away from certifying a vehicle. Talked about testing, which helps us with our risk reduction going forward, both for SpaceX and for Blue Origin. Talked about collaborations a little bit, our transfer of knowledge between NASA and each of the providers. And then I'll jump down to the engineering and safety human performance requirements. Ultimately, NASA is responsible for the mission, although we have services to provide where the providers supply the vehicle and the capability for 2 crew to land on the surface. The certification of the mission solely lies on NASA. So we have to perform the appropriate integration. We have to go and look at all the hazards. We have to be conscious of the risks that the agency is taking, and that is the responsibility of the Human Landing System Program Manager, along with the Artemis Mission Manager and the Artemis program. That's it.
All right. Thank you, Lisa, Emma, and Branielle. As promised, John Murator has performed a high-speed entry from Los Angeles and arrived here just in time. And we're really pleased you're here, John. John is the Lunar Trained Vehicle Service Program Manager at Astrolab. With more than 45 years of spaceflight experience, John is a systems engineer and former space shuttle flight director who specializes in bringing concepts to flight. He was a leader in the development and flight operations of the new Mission Control Center in Houston, the X-38 lifting body, NASA's Space Shuttle, and SpaceX's Falcon 9 and Starship programs. John specializes in taking systems from concept through initial testing and into operation. He combines traditional systems engineering with experience from NASA and SpaceX with rapid spiral development techniques for faster development. Please welcome John Murator.
First of all, my deepest apologies to my fellow members here. I literally started at 7 a.m. this morning. I was in LAX at 7 a.m. and I've been on airplanes the entire time, 3 different airplanes. So I'm very sorry, and I'm really glad to be here to talk to you a little bit about the Lunar Terrain Vehicle Program and what we're doing at Astrolab. Let's see. Okay, so this is what we call FLEX, the Flexible Logistics and Exploration Rover, okay? And it's about the size, it can carry about the weight of 2 F-150 cargo trucks. It's about the size of a large SUV. It can carry 3 metric tons of payload, about 1,500 kilograms at a time. It's intended to be able to operate robotically, exploring the moon, and also to be driven by astronauts driving the moon. It's deployed to the moon using the HLS. We did not want to have a separate lander system. NASA's investing huge amounts of money in the development of these 2 really terrific landing systems. And when Jared Matthews founded the company, the reason he did was he saw that there was going to be an entirely new era of lunar exploration that's going to be opened up by the human landing systems, because for the first time we're going to be able to bring large amounts of cargo down to the lunar surface. Normally, space exploration, we shave ounces off of things, right? And we even pay large dividends to pay ounces. Now we're going to be able to bring 100 tons at a time to the lunar surface. And the problem is, once you've got 100 tons in either the Blue Origin lander or the Starship on the moon, you got to do something with it. And there's a couple of problems you got to solve. First, you got to solve the last mile problem, taking it from where it lands to where where you're going to use it. And then you've got to move people to and from it. And then you've eventually got to be able to do construction to support it. And you've got to deploy hardware like solar panels to power it. And Flex is designed to do all those things. It's a modular rover. It combines heritage from JPL and the Mars rovers, along with the heritage of the LRV produced by NASA and Marshall. It puts those 2 traditions together into a hybrid vehicle that can either be operated telerobotically or operated by the human operator. And we're going to show you a little picture. Here's Flex. This is prototype number 1. This is actual full-scale prototype. This is running out in the desert in California, and Death Valley, actually. And here you see it operating. It's got a full 6 degree of freedom manipulator on it. It's got other tools. It's capable of driving at 18 kilometers per hour. It's got full sensors for operating in daylight or in dark. And that's really important because in the South Pole region, where we're most interested for water ice and other resources, there are places where we're permanently shadowed and where all the time it's always dark, and there are places that are permanently, or that are lit for long periods of time. The entire, and finally you see it doing a job where it's lifting and moving other robots and hardware. So let's see, we'll move on to, and you can see it here moving people. So the idea is, first we're going to be the FedEx or the DHL or UPS of the moon. Then our plan is to become the Uber of the moon, driving people to and from. And then we're going to start building power systems and communications networks. So we'll sort of be the AT&T in the moon and the Houston Power and Light of the moon, with a goal of eventual South Pole lunar domination. Let's go to next. This is the founder of our company, and you'll be interested to know that he's an ISU grad. Yes, he is, Jarrett Matthews. As a matter of fact, he and his wife are both graduates of the master's program, and they met at ISU. So there you go. There's an opportunity for romance out there in the audience. Jarrett is a mechanical engineer. He spent 10 years at Jet Propulsion Laboratory, 13 years at Jet Propulsion Laboratory, working on Spirit, Opportunity, and Curiosity, doing both design, development, test, and operations. He worked on a rover called Athlete, which is really kind of a lot of the core ideas of our Flex. Then he went to SpaceX, and where he was in charge of all mechanisms on the Dragon, and including he was the personal lead for the development of the Dragon docking system. So he brings a tremendous amount of experience to bringing systems to flight, and proof that a really nice guy can win in the long run. This is not such a nice guy. My background is very different. So I'm in a rover company, but you know, Jarrett's built rovers, and our chief engineer, Rias Billing, he led the builds on every arm that's currently on Mars. So these are real serious robotics people. So why am I doing at the company? I bring 3 skill areas. And I mention this because as you're starting to think about your careers, you not only think about the specific disciplines you learn, but you think about the kinds of tools that you develop. And the tools that I developed are, first of all, about bringing systems to flight. And I would encourage you, if you ever have a chance to bring a system to flight, you want to really spend time in that experience, learning what it takes to take something from an idea or it's sort of working to where you're ready to take it to flight. My second skill area is systems engineering, both in the small and in the large, both traditional and in non-traditional approaches. And that I learned a lot at SpaceX and with a project we did called the X-38. Anyway, that systems engineering is another skill, which is you always want to try to get some while you can in big programs. And then the third thing is I've been building infrastructure for the last 10 years. I led the teams that rebuilt Pad 39A for Falcon 9 and Falcon Heavy. Then I moved over to Cape Canaveral and with SpaceX and did Pad 40. Then I moved down to Brownsville, to Boca Chica, and John Hunt and I were the first 2 people on the ground at Boca Chica, and we actually drove around the earth-moving equipment that settled out the first pad. Then my last 3 years, I retired from SpaceX, and I thought, that's it. I got asked to go build a prototype nuclear reactor in New Mexico, and I thought, gee, I'd never done that before, so I'd go give that a try. I did that for 3 years. We got the prototype up and running. And then I retired again, and then Jarrett called me and said, hey, come over and help us out on LTV. As you can see, we've been testing the LTV out mostly in Death Valley, in the harshest environments. We've been driving it both with pressurized suits and non-pressurized suits. And we've been testing the manipulator mechanism, the bringing of the payloads, capturing them, transporting them, and dropping them off. And we did both day and night operations. The other thing we did was we worked on infrastructure there, I think. And here shows what Flex's role in the Artemis program is. Flex is a core rover that we can equip with crew modules and crew displays so that it can be driven by crew, or we can equip it for purely robotic operation. And we're launching the first one at the end of 2026 to the moon to do purely robotic exploration. And then when we first put it up on the moon, it'll do primarily robotic exploration and then support the crews when they come up. And this was from NASA's architecture document on the kind of distances that might be involved in a lunar base. And it's a really interesting cartoon because it shows the circle is a 2 kilometer circle, which is really about as far as you'd ever want to walk in a spacesuit, a pressurized spacesuit. And then what they did was they laid out, you know, how much distance do you need from things? How much do you need from landing sites to pressurized modules? How much do you need between ISRU processing, which will make a lot of dust, to the habitation modules? How far away from the habitation modules do you want the power augmentation? And as you can see, there's about 5 to 6 kilometers where where people on a lunar outpost will need to be able to move around quite a bit. And so that's what we're doing Flex for. And again, this is our total plan, which is first we're going to provide mobility services. And unlike other aerospace companies, Astrolab is completely devoted to surface transportation and infrastructure. We don't do flight vehicles, we don't do launchers, we don't do transfer vehicles or stages. Matter of fact, we don't even have any fluid engineers. We're all mechanical systems and mechatronics. And so our plan is first to provide the last mile transportation and then crew transportation, and then provide the capability to deploy infrastructure, and then actually operate the infrastructure and sell the infrastructure on the lunar surface. So thanks very much.
Thank you, John. So fascinating to see the pieces of Artemis come together. I have a couple of questions that have popped to mind listening to these presentations. So I'm going to take the moderator's prerogative and ask the first few tough questions of our panel, and then we'll open it up to the folks here in the auditorium. So first, Branielle, I know you might have felt this one coming, but Avcoat ablators. The Artemis 1 mission had a little, it didn't perform exactly as we thought with the ablators. What are we doing for Artemis 2?
That's a great question. Yeah, so for those that aren't familiar, when you return, right, many of you probably do this, getting out of Earth's surface is one thing, coming back into Earth's surface is a completely different kind of beast, so to speak. And so, especially when you're coming from lunar trajectories, you come in at such a steep angle and at a very high speed and a very high temperature rate. So Artemis 1, one of the main objectives of Artemis 1 is to test out our new heat shield. So utilizing technologies and testing and everything else over the past many decades with Apollo and understanding what Apollo did with its Avcoat. The Artemis 1 spacecraft actually is a blocked Avcoat. So meaning that we have multiple different blocks, I believe about 186 blocks. Probably fact check me on that one. But in piece parts, right, it helps from an assembly standpoint and everything else. And so when we came back in, one of the first things we found when it came back in was that, you expect char on your heat shield. That's expected. What was a little bit unexpected, because we hadn't seen it in our modeling, was a little bit of this char loss and unexpected conditions. So since then, our teams have done an extraordinary job about the last year plus in an investigation. Absolutely outstanding, and have actually been able to recreate that phenomenon. So we learned a lot, and that's what this test flight was. It's to learn and to grow and to be able to take what we've understood, how spaceflight actually behaves, and when we come back into Earth's atmosphere, and then apply it to our modeling to be able to recreate that same capability. So for Artemis 2, we're talking through that. The investigation team is wrapping up. We expect to have that out brief here this summer. So it's getting close to go forward with, but it's been outstanding to see what they've been able to uncover, and to be able to actually replicate that in a lab today just shows that space, you always continue to learn. And everything that you do, how you think your systems will behave on the ground, how you model them until you fly, you truly to get that input. So we're pressing forward here, but we're expecting to have that out brief at the end of the summer.
Thank you. And I think, as John says, getting hardware to flight is the giant leap that we all have to go through. All right, let's take a giant leap out to the moon with Emma. Emma, I think most people, when you tell them we're going to put a small space station around the moon, are like, yeah, that's a pretty good idea. And then you tell them, oh, it's going to be in near rectilinear halo orbit, and they look at you with a quizzical look. Why is Gateway in NRHO?
Fantastic question. So my strategic communications professionals who work on the program, by the way, have warned me against using the acronym NRHO, or so bravely as John did say it out loud, because it is something that you can trip over pretty easily, near rectilinear halo orbit. NRHO is a really stable, easy to get into and out of orbit that provides us a lot of flexibility. It has several other key benefits, particularly for something like Gateway. It allows us to access almost any point on the lunar surface. So Lisa's landers will be able to depart from the gateway and go to our most interesting target of opportunity, the lunar South Pole, or other locations around the moon. The Apollo missions really only landed, if you look at a map of where those missions landed, on the equatorial, the middle band of the moon, and now we are interested in lots of other places on the moon. The NRHO orbit also provides constant direct line of sight back home. So Gateway as a communications relay will always be able to provide comm back to Earth and act as a relay between the surface and home. So lots of reasons why this is a very interesting orbit for us to operate, have Orion and the landers come aggregate in this orbit that's easy to get into and out of.
All right, thank you. A little deeper into the gravity well, we have the HLS system. And Lisa, we noticed in your ConOps, and I think everybody here knows what a ConOps is, by the way, if we've taught them well. In your ConOps diagrams, you showed both the SpaceX and the Blue Origin system having to be refueled before going down to the surface. Can you tell us, and Apollo didn't do that, so why are we refueling a lander this time before going to the surface?
Another great question, John. So I talked a little bit about our objectives, being able to sustain crew on the lunar surface for a period of time and be able to do a lot more exploration. Interesting enough, Apollo objectives, it was more of a point-to-point solution. And so objective was to fly crew to the moon, land on the moon, walk on the moon, come back in a very small area of the moon. For Artemis, the intent is to explore. And to explore and be able to build and take those logistics and other payload capabilities to be able to build and be able to keep crew safe on the lunar surface, we have to have mass. And that mass can be either used to build up a robust, more robust, because safety is number one. We're not going to compromise safety for any cost. But to be able to have more mass, you've had to pull out something. And so both of our providers are building in the capability to be able to refuel in the lower Earth orbit or in the next orbit, NHRO. So what I want to talk about that capability. We've not proven that capability. One of the primary objectives here, knowing that we've got to build and be able to sustain on the lunar surface for a period of time as a lander, was to be able to launch, have the mass available to be able to do that. But propellant was what we all agreed would be the fastest and the most beneficial capability if we could have that capability in the lunar orbit and be able to refuel whenever needed. And so next year you should see SpaceX Starship be able to have a test, in-flight test, to be able to confirm that capability of being able to meet, to launch, and then later or prior to launch, other vehicles that can stage those propellant capabilities and then be able to dock to those capabilities to be able to fuel the human landing system and be able to go on either to Gateway or to the lunar surface, where we can stay for a period of time, unlike they did in Apollo, and explore, allow the crew members to explore either through a rover or some other method, and then be able to return back to Gateway or just meet Orion and be able to send the crew back home. So I hope I answered the question. I'm excited about this propellant transfer. It is a new technology. This is the innovation that NASA and Human Landing System wanted to be able to achieve over the long haul and be able to do that. And both SpaceX and Blue Origin are working toward that.
Thank you, Lisa. That was great. Now, all the way down in the gravity well, we have rovers. And John, one of our targets, our initial targets, are near the South Pole of the moon. The South Pole presents interesting challenges in both power generation and in thermal. Could you tell us how the Flex rover is going to handle the long shadows, the cold, and you know, the sunlight that only comes out intermittently?
Okay, well, there's no real magic to it. It's just a matter of engineering. So we're using a combination of active and passive thermal. So lots of MLI blankets, lots of heaters, and lots of battery power, and lots of solar power when you are in the sun to charge the batteries, charge the batteries back up. The rover, each flank of the rover, each side of the rover is like an upside down U, and on each leg of it is all battery packs, all lithium ion battery packs, and about 1.4 kilowatt on each side. And what we do is we have solar arrays that are normally they fold closed, but when we want to charge, we open them up and charge the batteries up. And then when we drive into a permanently shadowed region, what we use is we use heaters to keep warm. And what we do is actually we centralize all of our electronics all of our avionics is on a single cold plate. So we can either cool it with a radiator when we're in a hot spot, or we can warm it with a radiator and heaters when we're in a cold spot. So we specifically design the systems to meet those challenges. The arrays are designed so we can deal with the very low sun angle that was at the South Pole, and we can operate effectively whatever our azimuth is with the two solar arrays. We can charge the batteries up, and we carry enough batteries for 290 hours of permanently shadowed activity, of overnight hibernation activity. The NASA requirement for normal operations is about 150 hours. So we've almost doubled the amount of requirements. So we've just done it with pretty straightforward techniques, with insulation, with heaters, with a radiator, and then just proper engineering of it.
All right, thank you, John. All right, we're going to open it up now to the audience for questions. So we'll give up a couple of our microphones from here, and we'll put one sort of at each corner. So if you have a question, put your hand up, and we'll get a microphone to you. And it's really hard to see you from here, but I see hands up already. All right. And we'll just wait till we hear something. And please state your name and where you're from. Button is on the very bottom.
Hello. Oh, there we go. Bit loud. Hi there, my name is James Fettis. I'm from Australia. I'd like to thank each of you for your time tonight. It was a wonderful lecture, and also to ISU for putting on such an amazing distinguished lecture program. For my question, I'd like to extend on what John asked about the Artemis 1 heat shield, and I guess the response that with test flights, test flights are just that. You want to learn how your systems work in the real world. Now, of course, the next test flight for Artemis has humans on board, and so while you still want to learn, the stakes of those lessons are much higher. So I'd like to hear from each of you what that leap feels like, going from seeing your technology tested without humans to knowing that it has to take humans further than they've ever been and return them safely.
That's a great question. I don't know, do you want me to start here, or John down there wants to start? He's got lots of knowledge. It's unnerving. I'll be very honest with you. I've flown both unmanned and manned, and there's a real element when you put people on board. And the consequences are much, much greater. And you take that to heart, right? When you talk about your decisions, your willingness to take risk, what is acceptable and not acceptable. And it's a lot of tough conversations, but you know, there's a saying, if I can remember how it goes correctly, you know, trust God, but all else bring data. And you have to bring the data, right? Let the data talk to you and let the data tell you what it should say. And that's, you know, from a heat shield perspective, that's ultimately what we've done. We've allowed the technical teams to go off and look at the data, to be able to test it and to come back, you know, a little bit isolated, right, from any other element, right? Let them focus on the technical and the data that it brings, because you're absolutely correct. Once you put humans on board, it's a whole different element. And you know, Lisa and Em and I have opportunities to talk to the crew and to get their perspectives and their inputs. I think I meet with them on a monthly basis. You know, they're not just individuals; they're our friends, and we want to make sure that we bring our friends back home. And ultimately, you know, that's when we look at Artemis 2. Everyone asks me what my most excited. Are you going to be excited for the launch? Are you getting excited for it going in orbit? I'm like, no, I'm going to be excited when the hatch opens, when they're back on Earth. And that's going to be my most favorite day, because then we've done our job. You know, the thousands of people that do this program, that put their heart and soul into it, have looked at the data and validated. So I fully appreciate it. It's a much different perspective when you put the crew on board.
Absolutely, Raniel. Yes. Please clap for that. Yeah. Hey, I'll echo that exactly. So I used to work in the most complicated, frustrating machine that exists in this country. That's Washington, D.C. I worked at NASA headquarters, and I didn't know how far removed I was from the reality of human spaceflight and getting to know the crew. Moving here to Houston, working at the Johnson Space Center, getting to know our astronaut corps was so important to me. But we don't live near the center. We live up here in town, kind of close to where we are, here near Rice University. And I didn't really think many astronauts would live up there, but it turns out one of our neighbors was an ESA astronaut. And so not only do I know who this man is and that he's going to fly, but I've become friends with his wife. I know his 3 children. I know their dog. It really becomes real and sobering. And so as you're in the design and development phase, we have weekly, daily, multi-hour program board meetings where we're talking about latches and the shape and the size of a bolt. And it can be so easy to get distracted in those meetings, specifically as someone who is not an engineer, not a technical professional, and to start to think that you're going to multitask and do something else. But thinking about that crew safety brings it right back, and you know that you have to be paying attention in these early conversations, because every decision can lead to mission success. So.
Wow. So HLS launches without crew, but the mission includes crew. So we'll pick up crew once we get into outer space. And we take crew to the lunar surface, and we have to bring the crew back to be able to interface with a vehicle before transferring and coming home. And, you know, you should have heard me, because I kind of yelled in the mic, safety first, right? So while we are buying these services from each of the providers, we are also providing insight and collaborations, collaborations such as, you know, dust. What does dust do to the suit? How does it impact the crew members' ability to operate? You know, what we've learned over time is not just to be able to manage the launch and get to the surface. They're conducting operations. They've got to finish that, and then they may have to maneuver the vehicle to leave the surface or to get themselves home if there's some emergency. So from cradle to the end, when we land and that crew steps off that vehicle, we are covering all those areas. You've got flight operations that are so embedded in every part of the design while we're here doing joint tests, in-flight tests like you fly. A lot of people don't listen to that much anymore, but it's true. You try and get as close as you can with all the testings, with the tests that the crew will see, environments they'll see while they're in flight and on the surface. So it's important from day one as you write requirements. What do you think you're going to need the crew to do? What is it on the extreme side that you want the crew to be able to experience? And then what is it you need the crew to be able to handle to get back home? There's never a moment where we don't think about the crew. Never a moment. And so again, HLS launches empty. But we're all about how to make sure the crew has the capability to explore and then getting the crew back safely. Again, the only difference between what we're doing, and not only, but the primary difference is exploration between us and Apollo. And exploration cannot be accomplished solely by unmanned vehicles. We need crew to bring that evidence back, to bring that data back, to give us their experience so that it can help encourage and influence how we build the next vehicle, how we modify the next vehicle, and how to sustain ourselves on a lunar surface.
Okay, I'm going to do a scant emotional, and then we're going to talk philosophical for a second. So in my career as a flight controller and a flight tester, I've lost 22 friends in aircraft accidents. So it never gets easy, no matter what you do, no matter what you've done to prepare for it, it's still something that haunts you. So if you're going to be involved in this business, you got to understand that that's the occasional nightmares come with it. Now, philosophically, there are two ways to get ready to go fly a human in space or in an aircraft. The first is you study and think about the problem and simulate it and analyze it as best you can on the ground with test facilities and with analysis and modeling and simulation till you build a certain level of confidence that says you're ready to go. That's the kind of traditional model of getting ready to fly humans into space. The alternative is what's called rapid spiral development. And in rapid spiral development, what you do is you nibble at the problem. You try to solve one problem at a time in environments where you can control the risk. So for example, I got on an airplane today to fly here today. It took me 3 airplanes, including one that had a maintenance problem. But the reason I was confident in it is because every day thousands of airplanes fly, and the airline I flew on does that, and they're pretty practiced at it, and so I felt confident in their decisions. So similarly, what the approach that NASA took on SLS, and I want to just say that we all should be very impressed at how SLS flew so well on its first flight. It shows a tremendous discipline and commitment to modeling, simulation, analysis, attempting to anticipate problems, right? That's one approach, and it works perfectly well. And then the SpaceX approach, which is rapid spiral development, which was took engines and hardware and flew small prototypes in Falcon 1, and then expanded it up into Falcon 9, and then we went through 12 blocks of the Falcon 9 over a 10-year period where we were constantly introducing major upgrades, and we were building confidence in it each time. Well, the same thing we did with Dragon. The initial Dragon was going up to space station unmanned, and we gained confidence in the total operations and in the spacecraft until we got to Crew Dragon. And so I think there's two basic ways to get to that confidence, and I kind of think that we're moving more as a community more back to the rapid spiral, and I think it's a lot faster and a lot more effective, and I think it's something that really needs to be applauded. And you know, I think NASA's doing it in the CLIPS program. I think we're doing it in the rover program. It's clearly been done in commercial crew. It's going to be done in the commercial space station program, and I think that's one way to deal with the problem of putting human lives at risk.
All right, another question out there?
Hello, I'm Alejandro Garcia, originally from the Dominican Republic and also U.S. citizen. I would like to focus on the international component. Back in Apollo, it was American trying to beat the Soviets, but this time around, we're focusing on Artemis that has a coalition of countries. So I would like to hear from you that international component with the current initial stage of Artemis, but also as we think more of a sustained presence on the moon, that we might have settlements and so on. If you could put that dimension, I would appreciate.
John, I actually have a question for you. Do you remember what our rule was during the Vision for Space Exploration?
10 healthy centers, 9 healthy centers.
And no international partners in the critical path. We are a long way from that today, with our international partners being an absolutely critical part of Artemis. So starting kind of with the broader principles and legal framework, we have all of the signatories of the Artemis Accords. I think that gives you a good indication of just how broad our international partnerships could be in the future. Drawing a little bit of a distinction there between agreeing to principles of action versus being truly an embedded participant in the program. So for Orion and for Gateway, we have clear international partnerships with day-to-day down and in integration. Our international partners on Gateway are a part of every single meeting and decision that we make. It makes for really early days and really late nights, let me tell you, but it's fantastic to be working so closely with them. And I see kind of no boundary, no reason why we can't bring additional international partners into the Artemis campaign in the future and the entire Moon to Mars exploration initiative. NASA goes through a process of looking at our entire exploration goals, our architecture, defining needs, understanding gaps, and then trying to figure out how we will fill those gaps. Some things we will build or buy ourselves and work with commercial partners on, and some we need international partners to go hand in hand with us.
All right, let's try to get a few more questions in.
Good evening. My name is Mihaela and I'm a Romanian national. Thank you for tonight. It's really an honor to share the room with you. My question is the following. Both Artemis and Gateway are exceptionally complex programs, and they involve international cooperation, a very complicated supply chain, and technology yet to be demonstrated in the future. But at the end of the day, they are projects like any other project. They have timeline requirement, financial requirement. If you can spend a few seconds to explain how do you manage them, what is the process in this very competitive environment for budgetary allocation? Thank you.
If only we had a business person on the panel. And I think we have to go back to you.
Well, okay, it's Michaela, right? Yeah, let me make sure we understand the question. What you really want us to get to is how do we manage these complicated beasts, yeah? Okay. So each of us has a program governance and organizational structure where we have subject matter experts in every area, like business people, myself, systems engineers, folks focused on procuring common systems that we all share across all of our vehicles, flight operators, and we all have a variety of working groups, panels, decisional governance forums, culminating for each of us in a program control board. That is the venue where key decisions are made that are doing those exact trades that you're talking about, the technical versus the cost versus the schedule. And it is a almost, well, Branielle is living it right now. It can become a daily conversation. For Gateway and HLS, I'd say we're more on a weekly cadence right now, looking at the trades and having really, honestly, rough and tumble conversations amongst all of the parties. At the end of the day, though, someone has to sit at the head of the table and make a decision. And for us, those are our bosses, our program managers. And at the Moon to Mars level, Amit Kshatriya, who is the head of the entire Moon to Mars exploration campaign for NASA. Brenielle, Lisa, anything to add?
So you mentioned earlier at the very beginning, Emma, of how we all work together. And so that's really part of it as well, is not only do we have program control boards where individual decisions that can be made within the program, but then we will have joint program control boards as well, tri-program control boards, where you have all the program managers sit in and jointly make that decision or recommendation up to the Moon to Mars organization. So that's where that integration amongst, it's founded on some of those governances, and then it's founded on the Moon to Mars governance as well.
And let me end with one quick, this is where I should have started. It's all about authority, understanding roles and responsibility, and pushing decisions down to at the lowest level possible. I started to answer your question with a very bureaucratic, process-based answer. That's where I live. That's my daily life. But we are NASA. We know that we're a little old and slow compared to new space. But in order for us to have any of the rapid movement that we need to actually get this done on a reasonable timeline, you have to push decisions down to the lowest level and move faster.
Yeah, I guess I'll take the job that NASA has to do is infinitely more complex because of the international. Having worked at SpaceX and now at Astrolab, when you have a commercial relationship, it's a lot easier to work over the international boundaries. Right? There's still, elements of pride that need to get worked through, and you need to be aware of cultural differences. But in the end, you can always go down to bottom line dollars and cents. And it provides a very interesting way of easing the problem. So you can be working with people in 3 different countries, and it's not about the pride of their component that they're doing. It's not their national pride. It's a bottom line to them. And that makes it so much easier. And what you guys are doing is so much more complex. On X-38, we had ESA provided the nose cap and the body flaps, and it was infinitely more difficult than anything in the commercial venue that we've done. So my hat's off to you. I mean, it's what we're managing. What Tommy Holloway used to say was about the space station program was it was the most complex undertaking ever by man, right? And now we've upped the game significantly in terms of, because now the technical, at least we had expertise in tooling around on orbit. Now we've got a whole bunch of huge technical unknowns in addition to the problems of an international program. The big advantage is there are a lot of people like on this panel who grew up in the space station program and have a lot of experience in dealing with the international agencies. And the agencies are better too. I hope that helps a little bit.
All right, thanks, John. All right, next question, please.
Okay, the Artemis program aims to permanent base on the moon. And I want to know, are there any upgrades to the program components like the Orion spacecraft, the SLS, Gateway, such as changing the service module for Orion to something even bigger, or adding more modules for the Gateway? And that's it.
Yeah, no, great question. So kind of future upgrades, essentially, is kind of where you're focusing on that one. So yes, straight and simple, right? Artemis 4 is actually, SLS has a bigger, they're called the Block 1B, right? They have the EUS, can't remember what it stands for, something upper stage. Exploration, thank you, I knew someone knew it. And it's designed, right, for us to have the ability to launch a larger mass. Orion is also working to, our future European service modules to be able to, how do we hold more propellant? How can we create more capabilities on our spacecraft to allow feasibility, right, to allow flexibility? And that's ultimately what it is. And so You know, you make a great point, and I hope to encourage, as you build spaceflight hardware, or whatever it is, whether it's the smallest component or an complex machine, you have to create the capability for it to always constantly change. Whether that's a software system, whether that's capabilities of replacing components, you have to be able to design it to do that, because the world's constantly changed, right? Your cell phones today are going to be outdated tomorrow, and that's the beauty of our technology. So it gets much more complicated. The more systems that you have involved in it, how long sometimes it takes to build those systems. But ultimately, you're always trying to protect for that. So from Orion perspective, yes, we are looking at capability upgrades, SLS also. I'll leave it to Emma to talk about Gateway, and Lisa, Rachel.
I'll just add very quickly. We're in the early stage, but we know, and we talk across all of the programs to try and understand what the full capabilities of Artemis, what's needed, and that strategy of what technologies are here, what technologies are not, what do we need to mature in order to be able to develop those technologies in time to be able to, for example, take up large cargo to get it to the moon, and that kind of mass. We've got vehicles that wasn't necessarily built to do that years ago, but the evolution is, even with the idea of uncrewed missions to take just payloads. You see that now in other places. You'll see that along the way with, I think, vehicles like Orion and with the human landing system. So there's always the big picture of where we want to go as an agency and what Artemis will ultimately end up. And then it's what technologies support us working now. It's that build a little, test a little, and build a little, and keep building and keep building. So you scar, basically. You set yourself up to be able to expand those designs, expand that capability as technology becomes available.
So for Gateway, we need to fly the pieces that we have designed today, which takes us through the delivery of an airlock, but I am most excited to think about what could come next. And I don't see any reason, as long as we can control the space station and have enough power, to have new modules that we have not designed or thought of today dock and build out further versions of the Gateway. You guys are going to go to the Johnson Space Center tomorrow, I believe, and have a tour. You are going to walk through a walkway that gives you a beautiful view of something called the Space Vehicle Mock-Up Facility, and you are going to see mock-ups, training mock-ups of the International Space Station. And then you're going to see the training mock-up of our habitation logistics outpost, the first habitable volume of Gateway, and you are going to be shocked at how small it is. You are, especially in comparison to the 4-meter diameter ISS modules. So what could come next for Gateway, and thinking about using Gateway as a test bed for what we need to learn to do to go to Mars someday, it's going to be all about larger volume and potentially something like a Mars transit vehicle in the future.
Just from more of the commercialization side, one thing we're really looking forward to is the lunar communications relay system. Because although it's not essential to getting there, it is essential to doing anything useful there. And so that's something, and that'll undoubtedly involve both satellites in lunar orbit providing relay, as well as upgrading something called LEGS, the Lunar Earth Ground Stations, which will provide more ground coverage for direct-to-Earth comm. So that's that's an area where major upgrades are going to happen, which will cause big steps in capability. One of the things we did on Flex was, unlike previous rovers, if you look at the previous rovers, either lunar or Mars, they were always fully integrated when they arrived at their destination. They had all the capabilities they were ever going to use, fully wired in, built in, and they were able to use them. With Flex, we've put modular interfaces so we can pick up and add more modules onto the unit in operation. And we've already designed an excavator that can do about 150 pounds of rocks in about 10 minutes, and then you move to another spot and you excavate the next spot. And we've added excavators and shown how we could integrate that. We've done logistics pods, and we've done other kinds of things. So the key eventually will be to have as generic functional modules as we can, the way we do in earth construction equipment, that sort of thing. On the farm that my wife and I have in Oregon, we have one tractor, but I've got all sorts of attachments for it, right? I got an auger for it, and I've got I got a cart that I can drag things around. And I think that as we get through the basic operations of flying to the moon and we start doing commercialization, we're going to start using more items that are more modular and more generic interfaces, starting with lunar habitations. Something that we're really excited about is lunar power modules for putting up masts to put solar arrays up and get more power on the lunar surface, and then eventually communication relays. Maybe not where you had intended, but it's kind of the thought.
All right, John, thanks. And thank you all. Let's have a round of applause for our panelists. There is one last question, and this one actually goes in this direction to you guys. We are at the cusp of sending a new generation of astronauts to the moon. The Apollo generation, 12 astronauts walked on the moon. 4 of them are still around. They're getting up there in age, but we are on the cusp of a brand new generation of astronauts. I'd like to point out Artemis over here, by the way, the winner of Space Masquerade, which is an excellent, excellent costume. So, given that we are the next generation going to the moon, if you guys had the choice to walk on the moon, by a show of hands, who would do it? Nice. That, ladies and gentlemen, is International Space University. And that's the end of our program tonight. Thank you. There will be a reception over at Rice, back at Sid Rich, and you could finish up with any of the panelists, asking them questions over there. So thank you all, and a good evening. Okay.